So hello, everyone. I'm Carla. I work as a software engineer for Reliant. And I heard you've got scalability on your network. But what now? What do you do after that? So one of the most common questions among all the community is how we make our environment better, more efficient. But what is efficient? It's so broad, the word. It can mean so many things. So I can say that's all about time. It's about time when you catch yourself the need that you have to deploy a new node or a new application in your network. You need to puppetize it. And then you can run, for the first time, the Puppet at your node that you want to deploy that application, and it runs without any errors. But that's not fast. It's always going to happen, some error that you forgot about, some detail about it. So, and when your environment grows, you have to scale that. There's going to be more manifests, more Puppet code to manage. So you have to deploy more applications, and a different kind of node is going to appear into your environment. But the good thing about that is that there's going to be some similarities between them. I'm going to talk about that a little bit further in the talk. But when your environment scales that much, about thousands of nodes, you're going to have an exponential growth of your data that you have to manage, and a lot of manifest is going to take longer and longer to compile your Puppet master. And it's minutes, it's going to time out, it's not going to work. So the more manifest you have to maintain its code, and especially the data inside that code. That's what is most important for us right now. So to solve these issues, we divided to conquer. So the first issue that we had was the scalability of our Puppet master environment and the data management side of Puppet manifests. So to solve the scalability issue, we split our infrastructure. So we can see that we have only one source tree of manifest, and then we split our many sites that we manage into every one of them has one Puppet master, which will receive only the manifest that fits that site, and then all the agents from that site pulls all the information and compile, and eventually it will work. So the second issue, which is the data management inside that manifest, we thought about extracting them from the manifest. And how we did that, we wanted to empower our customers to use a friendly web page, so they just click around, click the edit button, and just fill an IP that it wants to change at its node, hit save, and it's done. He doesn't want to edit any code, and we don't want anybody to edit code. So we're losing for any data update that we have to go into our source code and update that only variable. It's waste of time. So we pour in almost all our manifest into this friendly web application. So we can see here it's our node environment with some variables that is used, like DNS server, and also, we manage firewall policies, which is sensitive data, and users. So it's really friendly how you can just click add an access key, and just it's going to be deployed on the node. So to do that, we use Hiera. How many of you have heard or used Hiera here? Wow, that's a lot. So for you who doesn't know it, Hiera is a way to look up data from a backend. So there's support for a lot of backends, and you can be on in your file system in a serialized data as JSON, or it can be stored into a database as MySQL or Postgres, or NoSQL database. And we choose a NoSQL database, Redis. Why did we choose that? Redis is a fast database, and it's a key value story. So, for example, the documentation matches exactly what Hiera do to look up many scopes that is specified there. So if you have this example, the Redis recommends that you have the key in this format, the object type and the ID of it, and the data that you want to carry to look up. So it's a little bit cut out. If we look at this example, we have 3 scopes here. The first one, which is site, a node, and its host name in the end, it's the most specific scope. And then the second one, it's a group of nodes, which we can use those variables to show that there are some similarities between the nodes in that group. And the last one is common, which is common to all groups, all nodes of that environment. So if we want to carry a simple DNS IP for that node, we are looking for the most specific one. Let's say that our host name is my server. So it's just going to look up at that variable. Hiera is going to look up for that. If it doesn't find it, it's going to fall back on the second scope, which is my group. And then if it doesn't find it again, it's going to use the most generic one, which is a generic DNS server that fits all nodes. But for that, we still manage the manifest declaring our types there and all the resources that we want to have. So to avoid that, we don't want to go there and edit the manifest and to add another type, to add another file, another user. So we developed this new Puppet function called Hiera resources that it can dynamically create the Puppet resources from the data look at it from your backend. And it's available at GitHub if you want to look up there. Just a quick example of how it works. It's just going to retrieve from the database this JSON, as we are using JSON for this case. And you can see that we have one Puppet type, which is not file, if you can see that. And we have 2 resources. The first one is called title1, and the second one is called title2. It's pretty simple. And if you just want to apply those resources into your node, you can call the Hiera resources from your manifest, or here it's just using the terminal, just apply the Hiera resources, and it's going to apply those resources into your node. So that's awesome. That's exactly what we wanted. We don't want to micromanagement manifest for 10,000 nodes. We don't want to repeat ourselves by adding data that is similar between many nodes at one time. So the workflow for our data management is this one. Yeah, it's a little bit cut up. You can see that there are users, and there are applications or mobile phones access our API, which was implemented using Grape, the Grape gem. And we can see here that the data is going to be updated from our front end and our API, and the models from our Rails application, which that web application is built in Rails, is going to persist all the data changes into our Redis server. After that, it's going to sync between all our Redis slaves that we have one Redis slave in each remote site that we manage. And from there, the Puppet master is going to look up that data using the Hiera Redis backend, and then the agent is going to apply that code. So here. And also, to make our life easier and the life of our customers easier, we can simply update a massive data by using a CSV file. So you go there, edit your CSV, just import everything, and you create all resources at one time. And as we're dealing with users, users almost every time it doesn't know how to work things or it makes mistakes. So we have some data syntax validation, especially for our network configuration, our firewall at the remote side. So we have validation for IP address, host names. So we prevent our users to save or update any data wrong. And one of the most important things, too, is about security. We want to ensure that only the authorized people can update the data there. So we added two-factor authentication to our application, which you just log into the system. It's going to ask you how you want to, if you want to receive a call or if you want to receive a CMS. And then you're going to receive or a push on your mobile phone, and you can log into the system. We also have some levels of permissions to access the data, so you can delegate people at your company to these can only edit those kind of software or those applications, or can only read applications, read data, and that makes more secure, just ensure who can and cannot update the data there. Also, one thing that is very important that we're implementing right now is the log of any data change. The source control that we have for our Puppet manifests is just to have versions of our Puppet code. It's not about have the versions about our data. We have to split that. So our Git repository has all the changes of code, and inside of the application, we have all the changes about data. That's really important to split them. Also, moderation. The customers are able to update, to approve, or reject any data change from their own employees. So this is the overview of it. And we have several sites that is using that architecture. And for each site, we have one Redis slave and one Redis server on our side. So after this, by having the data input validation and avoiding micromanagement of manifesting data on our source code, we lower the probability of human error on our environment, which lead us to Puppet runs without any errors and faster. And then we have more time to focus on our development and not on data management that our users know better about their data than we. So, yeah, thank you. If you have any questions, you can go to the microphone and ask, or ping me on RC. I'm online there too. Okay, you can. So it's going to be, it's a stream. So.
How are you actually versioning the data? Or are you versioning it, or are you just logging the customer's change?
Right now we're just logging, but it's kind of a version 2 because we have the diff between any changes. So it can roll back later and just, if any data is approved, the data is going to be syncing to our Redis server and going to be deployed at the site, but we still have the diff between the previous version. So it's kind of a data version 2. It's on our Redis application. Any other question over there?
I was just wondering what your use case is, like why are you giving your customers access to change IP addresses?
Oh, okay. We work with retail stores. So we manage all the infrastructure of the many stores here in the US, so it's easier for them to update any data that they have, like just a simple example, like the wireless password from their stores. So they don't need to call us and say, hey, I want to update that. Can you change the code and then apply it? So they just log into the system and change that variable and hit save, and it's done. Any other question? Okay, over there.
Do you manage all of your resources via Hiera, or do you have a combination of files and Hiera resources?
I didn't listen, sorry.
Do you manage all of your resources via Hiera, or do you use a combination of files and Hiera?
We're trying to bring all our variables to Hiera. We're still migrating everything. It's not all customers that's already inside of it, but we're going to reach that. Any other question? No, I guess not. Oh, one there.
So 2 questions. First, do you have any way to inject dependencies when you're importing with Hiera resources? Or when you're importing with Hiera resources, do any of these resources that come in have dependencies? Like, can you add require or notify?
No, actually right now we don't have dependencies between resources. But that's a good question.
And the other one, after a user saves something for a change to be made, is there something that triggers Puppet runs, or do they still run periodically?
No, we have to wait for the Puppet agent to pull the data. But in the future, we're already thinking about doing a push. So we're going to apply the change right away after we save them.
Is there anything in particular you're thinking about for what you use for that push?
No, not really. Not yet.
mCollective's pretty awesome, I hear.
Any other question? Okay. Anything you can ping me on IRC? Online there. Thank you.